So it's chapter 6. It is the last chapter of this, or it's the last section, sorry, of this chapter. And if you look at the title of it, it's called Coordinate Geometry. What are we talking about when we talk about coordinate geometry? Yeah, those grids, right? The graph, X and Y axis, points, all that kind of stuff, okay? So we're going to deal with the coordinate geometry, but we're going to use quadrilaterals. So let's get a little coordinate system going here. Tell you what, let's put this just a little bit off center. Use this area to write. Okay, so here's what they're going to do. This starts straight with an example. They don't really even teach anything, all right? Because you should know how to graph things, and they're just using the stuff that you know about graphing and the stuff that you know about quadrilaterals, and just combining them together. So here's example 1. And I'm not going to write down the question, but it's in the book if you want to see it. It says, classify quadrilateral ABCD as specifically as possible, all right? So a quadrilateral is pretty general, right? Give me a more specific type of quadrilateral. Okay, a square would be a specific type of quadrilateral. What would be another one? A rhombus, a kite, a rectangle, a trapezoid.
Diamond.
Yeah, we haven't really talked about diamond. Diamond, I believe diamond's just a square, but it's just rotated. Yeah, because if you look at a baseball field, right? If you look at a baseball field, we call it a diamond, but it's the same length from home plate to first to second to third back to home again, isn't it? So isn't it just a square, but it's just rotated? Yeah. So that's why we don't really have a diamond. But we also have parallelograms too, don't we? Nobody said parallelogram. All right. So we want to be as specific as possible. Out of all the stuff that we mentioned, what was probably the most specific thing that we talked about? A square is probably the most specific thing that we talked about. Okay? So here's what they give you. They give you 4 points. Write these down. So they give you point A, and we'll graph these. They give you point B. They give you C, which is 4, -2. And they give you D, which is 0, -1. Make sure I got them right. -1, 3, 3, 2. Yep. All right. So let's do this in a different color. We'll graph them. All right, so let's graph them. -1, 3. Let's see. Yeah, we'll just use one. -1, 3, 1, 2, 3. Right there. Still white. Why is it white? There we go. All right, there it is. Then it's 3, 2. 1, 2, 3, 1, 2. Up here, guys. 4, -2. 1, 2, 3, 4, -2. Guys, up here. 0, -1. There we go. Yeah, but the thing is, you can't just say it's a rhombus just because it looks like a rhombus, all right? We have things that we know about a rhombus. It's not a kite. It's not a kite.
Is it okay if I said it looks like a rhombus?
No. What did I just say?
Yeah, but he said it is a rhombus.
I didn't say that. I never said it was a rhombus. I never said that. Everybody else was saying that, but I said you cannot just say it's a rhombus because it looks like a rhombus. Now, spoiler alert, say that fast, spoiler alert, it is a rhombus, okay? But what we need to do is we need to show that it's a rhombus, okay? So what do we know about a rhombus?
It's got one.
Okay.
It's got one pair of
2 pairs of consecutive congruent sides.
Consecutive congruence? No, the consecutive would be a kite. The consecutive sides. Gideon? Okay, all the sides are equal. Absolutely. Everybody listening? So we could say all the sides are equal. So we could do that. We could. Gavin, I've waited for you like 3 times just in the last 12 minutes. It shouldn't happen. Just pay attention like you're supposed to, like a real student does. So here we go. You could show that all four sides are equal to each other. Now, they don't do that in the book. I'm not really sure why they don't, but you could, all right, find the length of all four of these sides. How would I find the length knowing the points of all of them? What is it? The distance formula, right. I could do that, but they don't do that in the book. I'm not really sure. But we do know, they talk about the diagonals. What do we know about the diagonals of a rhombus? Do they bisect each other? Are they equal to each other? They're perpendicular. Okay, the diagonals of a rhombus are perpendicular. And that's kind of where they go with this. That's one of the things that they do. Now, they do actually four different parts. I only did 3 of them. So I'm not really sure if you have to show all of those things. I really don't think you have to. I think you can just show maybe I think what they're doing is they're testing to see if it's other things as well, okay? Not just a rhombus. They're not just testing if it's a rhombus. They also test to see if it's a rectangle. Now, looking at it, it definitely doesn't look like a rectangle, does it? But again, we can't just go by what it looks like, all right? Now, since they did give us the points and we have a perfect graph right here, we could be pretty safe to say it's not a rectangle, but they want to show that it's not a rectangle, all right? So if it's not a rectangle, then it's not a what? Square, okay? So you don't even have to do a test for that, do you? Okay, if you know it's not a rectangle, you know it's not a square. You could test to see if it's just an ordinary parallelogram, okay? Because just looking at this, I can't be 100% sure that this length and this length and this one are all the same. They kind of look like they are, right? But I can't just assume that they are. So I could just see if it's a parallelogram. And to tell you the truth, that's what I'm going to do first, okay? I want to see, is this a parallelogram? So how would I test to see if it's a parallelogram? What about the sides? Let's get the slopes. Very good. Okay, I would get the slopes of the opposite sides. So this slope right here, I'll tell you what, let's put the letters in here. -1, 3, that's A. 3, 2, that's B. This is C. And this is D. All right? So A, B, and DC should be parallel to each other, right? And then AD and BC should be parallel to each other. Now, with coordinate geometry, how do I show that AB and DC are parallel to each other? Say it. What about the slopes? They have to be the same. They got to be equal to each other, okay? They got to be the same. So let's do that. Let's find the slope. Let's go back to white here. Let's find the slopes of AB and DC. So I'm going to write M for slope. I'll just put a little AB right there. Now this is going to test your knowledge, your remembrance of if you know how to find the slope. Remember how to find the slope? Change in y over the change in x. So we subtract the y's, put them on top. We subtract the x's, put them on the bottom. So AB. So which one are the y's? 3 minus 2. Let's subtract the x's. -1 minus 3. And what is that? That's 1 over -4, or just -1/4. Agreed? Just put it. We could put it out front. It doesn't make any difference. All right. Now, if DC was parallel to AB, what should the slope of DC be equal to?
No, I mean -4. -1/4.
Negative. It should be the same. All right. So let's do it. So it's the slope of DC. So let's try that. All right. So DC is right here. We could say CD or DC, doesn't make any difference. So it doesn't matter what order you subtract them, as long as you subtract the y's and the x's in the same order. So I'm going to go -2 minus what? Not just 1, but -1. Then I'm going to go the x's, 4 minus 0. And then what's going to happen with that minus? It's going to go plus. Okay, -2 plus 1 is -1 over 4. Check it out. They are the same, aren't they? But is that enough? Just finding 2 sides? No, because it could be a trapezoid. If you only have one side that's parallel, it could be a trapezoid. So we have to do another test, and we got to see if the other 2 sides are parallel to each other. Okay?
A, B, and BC. Do we have to find AD or no?
Sure. If I find AD, how do I know if it's parallel to BC? Because I haven't found. This is DC. Right? All I've shown was that this and this were parallel. Now I got to show that AD and BC are parallel. So I can't just find the slope of one. I got to find them both and compare them, right? And just make sure. Now, again, this one's pretty obvious. Doesn't it look like it's pretty obvious, like they're parallel to each other? But let's do it anyway. So what do we got? AD. So let's find the slope of AD. It really doesn't take us that long to do the slope, does it? So A and D, what do we got? 3 minus negative 1. And then negative 1 minus 0. So let's figure out what that is. That's 4 over what? Negative 1. Okay? So it's negative 4. Agreed? Are they negative reciprocals of each other?
Yes.
Wait, no.
Yes.
No.
Why no?
It's not. That would be a positive.
That's right. They're not negative. They are reciprocals, but they're not negative reciprocals, okay? If they were negative reciprocals, what kind of an angle would we have had right there? We would have had a right angle. They would have been perpendicular, right? But they're not negative reciprocals, are they? All right, because this is negative and this is negative right here. Okay, so let's do the last one. So we did AD. Let's find BC. So the slope of BC. And they're right here. So it's 2 minus negative 2. And then it's 3 minus 4. See how easy it is to do slope now? Remember how we struggled with that? Well, maybe. Some people did. What's this? 2 minus negative is positive, right? So it's 4. 3 minus 4 is negative 1, and that's negative 4. So are these parallel to each other? Absolutely. So we know, at the very least, it's a what? Parallelogram. Actually, at the very least, it's a quadrilateral. But getting a little bit more specific, it is a parallelogram. So we know it's not a rectangle because those sides are not perpendicular to each other, correct? All right, so we can rule that out. We can rule square out. So what's another thing we need to find? We need to find, it could be a what? A rhombus, right? So we haven't shown that it's a rhombus just yet. All we've shown that it was a parallelogram. So let's show that it's a rhombus. We could, if we wanted to, find the lengths of all 4 sides, right? But that's 4 things we got to do. That's a lot, okay? Especially with distance formula, because that's a little bit more involved. What's something else that we could do? What's something else that we know about a rhombus? The diagonals are perpendicular, okay? So what we could do, we could just find the slope of the diagonals. So let's put this in a different color. So from A to C, all right, and then from D to B or B to D. Okay. So look, see the pink ones right there? If we can show that they're perpendicular, and they kind of look like they are, don't they? All right, but can I just go by they look like they are? No, I can't. No. I can't just look at it and say, yeah, it looks like it's perpendicular. I can't do that. So I have to show that they're perpendicular. How do I show it? Again, I find the slopes. But this time I'm finding the slopes of the pink lines instead of the yellow ones, okay? And if I can show that they're negative reciprocals of each other, then what is this thing? Then it's a rhombus, okay? Because that's the only time when the diagonals are perpendicular, okay, is if it's a rhombus, all right? Now we've already ruled out it's a rectangle because we compared the slopes, right, of this side and this side. They are not negative reciprocals of each other, so we cannot say that it's a rectangle. So we know it's not a rectangle. We know it's not a square. Let's see if it's a rhombus. All right, so we got to do slope one more time. So the slope, what's the slope? What are we going to find the slope of? AC. So let's find the slope of AC. So let's do that. Here's A, there's C. It's pretty easy now. 3 minus negative 2. And then AC, again, it's negative 1 minus 4. And what do we get? That's 5 over what? Negative 5. So what's the slope of AC? It's negative 1. It's positive over negative, right? So it's negative. Okay, you with me? All right, let's do the other diagonal, which is what? BD? So let's find the slope of BD. All right, here's B and there's D. Let's subtract the y's. 2 minus negative 1. And let's do the x's. BD, which is 3 minus 0. What's that? 3 over 3, which is 1. Are these negative reciprocals of each other? Absolutely, okay? I mean, it's a 1. You're like, oh, it's not a reciprocal. Yeah, but the reciprocal of 1 is 1, right? Okay, but one's negative, one's positive. So there's your negative reciprocal. Everybody got that? So what do we know about these 2 pink lines right there, AC and BD? They are perpendicular right there. So if the diagonals are perpendicular, then this thing is a what? It's a rhombus. Okay? And there we go. We just showed that that's a rhombus. We good? All right. I think we probably, I'm not 100% sure on this, okay? But I think we probably could have just done this part right here to say that it's a rhombus, okay? I don't think we had to show that it was a parallelogram, but I think that's what they wanted you to do in the book, because they actually find the lengths of the diagonals. Now, because they want to look at it and say, I wonder if this is a rectangle or not. And the test to see if it's a rectangle is to look at the perpendiculars, look at the diagonals. If the diagonals are what? Then it's a rectangle, if they're equal, right, if they're congruent. If the diagonals were equal to each other, then it would be a rectangle. So if you wanted to, and I did it on my notes, they do it in the book, they actually use the distance formula. They find the length of AC and the length of BD. They showed that they're not equal to each other because one was the square root of 50, one was the square root of 18. They are definitely not equal to each other, so it's not a rectangle.
I know that it could be easy to find just to see if the diagonals are perpendicular or not. I mean, that leaves you with two options, but then it's still a debate on whether it's a rhombus or a square.
No, he's got a point.
A square's diagonals are perpendicular.
Right, because a square is a rhombus. He's absolutely right. So, but right here, I think we did enough right here to show that it's not a square, it's not a rectangle. Okay, they don't even talk about that in the example when they did it in the book. But I think just showing that right there means it's not a rectangle. Okay, so I think that's good. All right, enough of that. So that's the kind of stuff that we're going to do. Let's do a little bit more, okay? Now, that was the easy part, okay, because they give you points. You just got to do a test for it. But this one, they're going to leave some stuff out, and you got to figure out what is left out. So here's example 2. It says, well, I'll tell you what. Let me put a graph here first. And it's very helpful if you do have a nice little graph. You can use graph paper if you want. I haven't even talked about using graph paper in there. I'm not going to make you use graph paper, but some people, you bought a whole pack of it at the beginning of the year, and if you haven't used it yet, might be a good chance to use it, right? So everything looks nice. Like when I did my own notes, I just hand drew lines and the little tick marks and all that. And so my stuff didn't look like exactly like it should have. But if you use graph paper, you should be right on, all right? So if you want to, you can. You don't have to. Sometimes I'll do this. I didn't do it last night, but sometimes I'll use a ruler, right? And my little marks, right, the little grid marks right there, I'll take like a centimeter or a half a centimeter or something, whatever it is, or a couple millimeters or something, and put my little tick marks to make sure that everything's nice and even, all right? So anyway, enough of that. Let's do this. Here's what they ask. They say, find the coordinates of F and G. So I want to find the coordinates of F and G, all right? Now, it says if the diagonals of this parallelogram, so they tell you that this is a parallelogram, EFGH. You're writing this down and stop making stupid noises. Okay? I know it wasn't him this time because it came from over there. Intersect at point. All right, this one's a little tougher, so this is not the time to relax. It's not the time to just quit. We got 20 minutes left in here, okay? So we got a lot more to do. Here's what it says. Find point F, okay, the coordinates of F. So I need to find, right, what the point is, right? 3, 2, negative 5, 1, whatever, okay? And then I also have to find the coordinates of point G. Now, they tell you that you have a parallelogram, EFGH, and it intersects at, and they tell you something else too, don't they? Do they tell you that's 4, 1? Anybody got their book open? Yeah. Yeah, they say that H, I didn't write that down. I put it on my picture, but they say that H is 4, 1, and E is 0, 0. I think they drew that on the picture itself, didn't they? Yeah. All right, so I'll just write them down, though. All right, so this is the information they give you. Everybody see it? All right, F and G. Now, what do you know about a parallelogram and the diagonals? Because it says the diagonals. I should write that in. I'm not going to. I'll just shorten it. The diagonals of this parallelogram intersect at this point right here. What do we know about a parallelogram and the diagonals? The diagonals do what in a parallelogram? They bisect each other, okay? Everybody remember that? That's important to this, okay? Because as the diagonals intersect at 3, 2. So that's the point, that's the middle point of both of the diagonals. Does that make sense? Okay. So let's draw this thing out as much as we can. Can you see that pink all right? Could you see that pink from before? All right. So let's put some points in here. 4, 1. 1, 2, 3, 4, 1 right there. And then 0, 0 right there. And then T, which is the intersection of the diagonals, is at 3, 2. 1, 2, 3, 1, 2. Okay? So we got to find F and G. All right? So watch this. It doesn't? Yeah, I think it is. All right, so let's put some points in here. This is E. Oops. This is E. This is H. Now watch this. I want to find point F and I want to find point G. I know H. What did I say that was? 4, 1? All right. So here's what we have. Here's EH. I got to find F and G. Well, this is the midpoint of the diagonals. So let's do this. How did I get to that? I went over 3, I went up 2, right? So where do you think the other point's going to be?
I don't know.
This is the middle.
Over 3 more up 2.
That's right. If I go over 3 and up 2, then say it again. Over 3 and up 2 more. You see that? Won't that be the midpoint of this diagonal? Because I'm going from E to what? G? Everybody see that? So if this is my midpoint right here, right? So this is point G. Yes? All right. I'm going to show you mathematically how you can do it. You could just count, but this will help me draw my picture at least, won't it? So that's right there. And so where's the other one? So let's see. If I go from H, right? If I go from H to the midpoint, right? I go up 1 to the left 1. So what am I going to do from here? Up 1 to the left 1 right there. And then I connect from here to here. And then I can connect this one to this one. Everybody see that?
Is that a kite?
No.
It's a parallelogram.
They tell you it's a parallelogram. See? They told you that it's a parallelogram. All right? So this is 4, 1. Now, if you used a graph and you made it nice and perfect, you probably could just count over and find out where G is, count over and find out where F is. Okay? Let's just do that just for fun. Okay? So where is point G? Well, this is 1, 2, 3, 4, and then what? 5, 6, and then 1, 2, 3, 4. So this should be 6, 4. Agreed? If you used a graph, if you used graph paper and everything was nice and perfect, now if you just kind of sketched it, right, on your paper and just hand drew it, you may not be able to get that accurate. But with graph paper, we can. But we're going to show you another way to do it, though. All right, what about point F? What's that? 1, 2, 1, 2, 3. So this should be what? 2, 3. Agreed? Let's see if we are right. So, oops, let me do this. Let's go back to white. All right. Remember, this is the midpoint of the diagonals. Let's put the diagonals in there. Why is that funny? Okay? You with me on that? So those are your diagonals right here. This is the midpoint of the diagonals. And we can, yeah. So, let me see how I want to explain this. Oh, okay. Now look, now remember, I put 2, 3 and I put 6, 4, but originally we didn't know what they were, okay? Are you with me? Right? Originally we didn't know what that was until I started counting. But I do know that this point in the middle is what? 3, 2, isn't it? Everybody see that? So that's my midpoint. That's the midpoint of FH. Everybody look at FH. Everybody with me? Remember, technically we don't know that's 2, 3 just yet. Okay, we want to find it though. We want to find it using this coordinate stuff. So, so this is the midpoint of this FH. Yes? So the midpoint is equal to what? 3, 2, isn't it? Yeah. And what's one of my other points that I actually know that they gave me to begin with? It was this one right here, which is 4, 1, right? So they give me one of the endpoints is 4, 1. What am I trying to find? I'm trying to find this other one right here, right? So we'll just call it XY. You with me? So what we're going to do is we're going to use these 3 points. One of the points we don't know what it is. That's what we're going to try to find. All right? But we know the midpoint. Do you remember the formula for midpoint?
Oh,
It's an ordered pair.
X1 plus X2 divided by 2.
Yep. So they're both divided by 2. To find the midpoint, you take the 2 x's, you divide them by 2, and then you take the 2 what? The 2 y's, and you divide it by 2. Everybody with me? Okay. So now, this is where it's a little tricky. Okay, because normally, like on a test or a quiz, what do we usually give you? I give you 1 point, I give you another point, and you have to find the what? The midpoint. But this time, I'm changing it a little bit. I'm giving you the midpoint, and I'm giving you one of the endpoints. You got to find the other endpoint. You see what we're doing here? Because the information that they give you. Because they don't give you both endpoints. All right? They only give you the midpoint and one endpoint. We got to find the other endpoint. You see the difference? All right, so it's a little different, but let's do it. Now, we actually know what the midpoint is. What is the midpoint? It's 3, 2, isn't it? Okay, I'll show you what to do. This might be a little bit weird at first, but it's actually works out nice. So watch. I'm going to add up my 2 x's. Now, I know one of the x's is 4. The other one is just a variable. So I could just put x plus 4. Everybody see that? Because I just add up the x's. What's this going to be then?
Y plus 1.
Y plus 1. Good.
It's 4x.
It's not 4x. It's just x plus 4. Okay? You with me on this? Now, what in the world do we do with this? I've never seen anything like this before. This is kind of weird. But look at this. This right here should equal what?
3.
3. Exactly. Because look. See, this midpoint is equal to this midpoint. So the 3 is the first one, and this is the first one. So the 3 is equal to this. And talk to me. The 2 is equal to this one right here. Everybody see that? So that was a little different, right? We hadn't done that before. All right, so let's set it up. Let's say x plus 4 over 2 should equal what? 3, because this is the x coordinate, right? This is the x part of this midpoint. Well, 3 is the x part of the midpoint, so I set them equal to each other. Let's do this. What's this going to be? That should be easy, right? Since you saw that first one. So y plus 1 over 2 is equal to what? 2. And now we can do the math. Once we do the math, that gives us this point right here, xy. All right? We can do this easy. Multiply by 2, what do you get? 6. Everybody see that? You get rid of something that's being divided by doing the opposite, which is multiply. So you multiply by 2, subtract 4, x is what? 2. Do the same thing here. Multiply by 2, you get 4. Subtract a 1, y is 3. So what's my ordered pair then? It's 2, 3. Isn't that what we said it was going to be? There it is, right there. It's exactly what we said it should be. Okay? And then you do the same exact thing to find g. That's right. So you got the midpoint, right? You know this is 0, 0. So that actually makes it a little bit easier, right? Because this is 0, 0 right here. You want to do that real quick? Yeah, let's do it real quick. Let's use a different color. All right, so again, we have 3, 2 as our midpoint, right? Because it's the midpoint of both of them. Because remember, they bisect each other, right? So they both share the same midpoint. Agreed? So 3, 2 is equal to x plus what? 0 over 2 and y plus 0 over 2. Because remember, the other point was 0, 0. All right? It's a little bit easier, I think. So let's set, what's x plus 0? It's just x over 2, isn't it? X plus 0. Well, x plus 0 over 2 is equal to 3, but x plus 0 is just x. All right, so x over 2 is 3, and then y plus 0 is just 0. Or I'm sorry, y plus 0 is just y over 2, and that's equal to what? This 2 right here. Multiply by 2, x is 6. Multiply by 2, y is 4, so your ordered pair should be 6, 4. Is that the one that we found up here? Absolutely. It's 6, 4. It's pretty cool, isn't it? All right. So without even drawing this thing, even if you weren't able to count over and up and get a nice perfect, parallelogram out of it, you still could have done this. All right. Yeah. So write it down, go back, watch it again, watch the video again, or at least this part of it, if you didn't quite get it today. That's why I do these videos. All right. We got a little bit more to do. I'll probably finish it up tomorrow, but let's do. Oh, actually, okay. Yeah, I don't know. We might be able to. No, we are having homework tonight. Oh, come on. It's on the thing. It's on the lesson plan, right? You know, all week we're having homework tonight, so come on. There we go. All right, here we go. Ready? It says, find the missing coordinates. And they actually draw it for you. But it's weird that they don't give you really any, numbers. Are you looking at the book? Example 3. They just pick a number. I'm going to go up here like this. I'll just go right. It's chapter 6. So right there. Now, they don't say to go up exactly 3. They just say you're going up. Well, I'll tell you what they tell you in a second. But I'm just drawing this. Let's say 1, 2, 3, 4. I'm just trying to make it kind of look like it looks like in the book. All right? So it goes like this, like this, like this. All right, but they give you different information, and the information they give you is a little bit weird. It's a little bit different. So it says, first of all, it says it's a rhombus. They tell us it's a rhombus. We don't have to prove that it's a rhombus. They tell us it's a rhombus. J, K, L, M. All right, this is the J. The K is up here. This is the L, and this is the M. Okay? Now look what they tell you. They say that it has diagonals of length. Now this is where it gets weird. Okay, everything else is fairly normal so far, but they say it's got diagonals of length 2W and 2T. What in the world? Well, let's take a look. I'm going to go different color here. The diagonals have a length of 2W and 2T. Well, here's our rhombus. Where are the diagonals? Well, JL is a diagonal, isn't it?
No, wait, is it? Yeah, yes, it is.
Sure it is. Yeah, that's a diagonal. That yellow doesn't really show up there, does it? Let's make it blue. That's okay. Good enough. All right, and this is a diagonal as well, isn't it? Boom, right there. They kind of show up. It's not that great, but anyway, you can see the lines. So it says they have lengths of T or 2W, and by the way, they call this one. I think they tell you this one right here is W0, don't they? Yeah. So along here is the W, up and down is the T's. So if this is W0, what is the length from here to here? What is the length from the origin to this point right here at L? What is the length of it? Not 2 times W. Look at this point. Look at point L. How did you get to that point? You went... No, listen. You started here, and you went to here. What's that point? It's W0. Like stick a regular number in there. Like count 1, 2, 3, 4, 5. 5, 0. So what was the length from here to here? 5. But we don't know it's 5, right? We know it's what? It's W. So what's the length from here to here? It's W. It's W. W represents any number, right? They don't put this on a graph paper. They just put the X and Y axis there, all right? So what is the length from here to here? It's W, okay? And that should make sense because the diagonal length, the diagonal length is 2W. So watch. If this is W, this length right there is W, what's this going to be? This is going to be W because the diagonal is what? 2W, right? And what happens to the diagonals in a parallelogram? They bisect each other, right? So if the whole thing is 2W, then this has got to be 1W, and that's got to be 1W. Then what's true about this? From here to here is 2T, so this length's got to be what? T, and this length's got to be T. All right? Everybody with me? Now, the question says, find the other coordinates. We already know this is W0. All right? Let's go back to white. And let's find point J. Let's find out where that is. Let's find K. And let's find M. That's what they're asking for. They're asking to find those coordinates. So what would the actual coordinate of J be, point J? You start here, and where do you go? You go this way, so it would be negative W. Then how far up and down did we go? 0. You with me? Now it's starting to get a little easier, isn't it? What about K? How did we get up to K? Well, you went what? 0 first, right? So you went 0, and then how far up did you go? You went up T. And then what about point M? You start where? Here, and you go 0 first, and then you go what? Negative T. All right? It's hard to get used to putting variables in there instead of numbers, right? If I said that this, if I told you just to count, that would be very easy. You could have just said, oh, this is 0, negative 3. All right? You just got to get used to having variables in here, right? Not knowing. Now, I did put this on a graph paper. They don't do that in the book, all right? So they don't tell you like exactly how far it is, but it is T. There's one more example with a trapezoid. It'd be nice if I had time to finish that, but I am going to give you the homework, though. So the homework is still due, and it's, let me flip my page to it. It's 1 to 7, so it's section 6, section 6-6, and it's numbers 1 through 7. It's page 289. All right, so that's your homework. Okay, there's not that many problems, but you got to think about them, though. Okay, so it takes a lot of thought on this compared to what you normally do.